How much do you remember from grade 10 science? What was the unit in grade 10 science in the physics? It was all about ramps and motion and cars and stuff like that, right? And that's why everyone thinks that that's what physics is. It's where we start usually, okay? Before we can do any of that, I want to make sure that everyone can graph. I want to make sure that you're all at the right sort of page. Everyone's caught up on graphs. Many of you, this will be review. Some of you just need a little refresher, okay? So a well-designed graph is more than a picture with 1,000 words. It can give you more information than either words, columns, or columns, numbers, or equations. To be useful, however, a graph must be properly drawn. In this section, we'll develop the use of graphs to display data. Graphing data. One of the most important skills to learn driving a car is how to stop it safely. No car can stop on a dime. The faster the car is going, the farther it travels before it stops. If you studied for a driver's license and driver's ed, you probably found a table in the manual showing how far a car moves beyond the point at which the driver makes a decision to stop. Do they teach you about that in driver's ed? No. Stopping distance? Yeah. I would hope so. They tell you about like how many car lengths to leave and stuff like that, right? Okay. One manual shows that a car travels a certain distance between the time the driver decides to stop the car and the time that the brakes are applied. This is called the reaction distance. Does that sound familiar? Yes? Okay. Highlight that. If you have a highlighter or underline it or whatever. The reaction distance. If I asked you to define what the reaction distance is, what would you say? It's the distance the car travels. Yes, it's between the time that the driver decides to stop and it actually begins to stop. It's basically how far you go when your foot goes from gas to brake. Right? It's your reaction time, right? It's your reaction time. When the brakes are applied, the car slows down and travels the braking distance. I'm going to make this a bit bigger for you. The braking distance, right? The braking distance is the distance that you travel while you're actually braking, while your foot is on the brakes. Okay? Two different things. Table 1 in the bar graph, figure 1, show these distances together with the total stopping distance for various speeds. So, your first job today, the first thing you're going to learn is the magic number, is what I like to call it. Mitch asked about metric. We're going to be dealing a lot with meters per second. How fast is 10 meters per second? One, 2, 3, 4, 5, 6, 7, 8, 9, and a little bit. 10. Basically, the room is 10 meters long. Okay? How fast would I have to be going in kilometers to travel that distance in a second, do you think? Pretty fast? That's two different answers. He says really quick, you say not so quick.
10 meters a second for someone to run is pretty fast.
Like it's just normally jogging pace.
Oh yeah. Like
10
for
meters
me,
a second? You jog that? You jog 10 meters a
10
second?
meters a second. How fast does Usain Bolt run? He runs 100 meters
10 seconds.
in a little less than 10 seconds.
So that's just not that fast, eh? Not fast at all.
It's pretty fast for a human, not so fast for a car. Does anyone know the magic number from meters per second to kilometers per hour? I'll give you a hint. It's 3.6. It's magic. Do you want to know where the magic comes from? Because there's never anything really is magic.
I don't believe it is called magical.
Do you want to know why it's 3,600? It's because how many meters in a kilometer? I'll give you a hint. 1,000 meters in a kilometer. How many seconds in an hour?
1,000.
60 seconds in a minute. 60 minutes in an hour. What's 60 times 60? 3,600. If you take 3,600 and you divide by 1,000 meters in a kilometer, you get 3.6, the magic number. So it's not magic, it's math. Okay, your job is to get your calculator out. Nate, you're going to have to beg, borrow, or steal. Please use your phone if you need to.
I don't know phone.
Okay, well then you're going to have to beg, borrow, or steal. I want you to take 10, 15, 20, 25, and 30 and multiply by 3.6. I can do the first one in my head. What's 10 times 3.6? 36. Usain Bolt, when he's running the 100 meters for the gold medal, is running about 36 kilometers an hour. That doesn't sound that fast at all. I drive down my street at, well, twice that speed sometimes. That's right, I don't drive any faster than 50 down my street. Right? 36 isn't that fast, is it? Hey, 36 kilometers an hour, and you're going from this wall to that wall in a second. Yeah, you can't. Humans can't. The average human can't do it, right? 36 kilometers an hour is pretty fast. What's 15 meters per second? 54? Put one of the next numbers. Pardon me? 72? 90, I think it's like 108, isn't it? Okay. When you're driving down the highway at 108, because I know you do, I'm the only one in the room that probably drives at 100. When you're going down the highway at 108, you are going 30 meters per second. You're going from that wall to this wall, and all the way through Mr. Smigalski's room, and all the way, basically you're going the entire length of that hallway in 1 second. I dare you to run down that hallway with your eyes closed. You won't do it, but people take their eyes off the road all the time. Sometimes to do what? I dare you to run down that hallway at 30 meters per second with your eyes closed, because that's what you're doing when you're driving down the highway in Texas. One of you won't be at the game tomorrow. Okay. Reaction distance. What's this distance again?
Reaction time from your test.
It's how far you go
Or how far you go when you
before your foot hits the brake. If you're going 36 kilometers an hour, you go 7 meters before your foot even hits the brake, and then you go another 9 meters for a total of 16 meters before you stop. That's a long ways. If you're going 100 down the highway, 108, you go 20 meters, 22 meters before your foot hits the brake, and then you go another 82 meters. You're going over the length of the football field, almost, sorry, 104, I guess, not 110. You're going 100 meters, the length of the track, in before you stop. That's how far you go. That's a long ways. Be careful when you're driving, Nate. And everyone else, too. Be careful. Were any of you guys outside last year when the police came and we did that skid test outside?
No.
No? Okay, we'll probably reschedule that. I usually do it in the spring. It's usually like May long weekend, so yeah, watch for that, listen for that, and maybe you can get out there and watch that. We actually measured you put the car up to 60 kilometers an hour, hits the brakes, lays a big skid mark, and we can figure out from the length of the skid mark how fast the car will go. It's pretty cool. Okay. The first step in analyzing data is looking up carefully which variable did the experimenter or the driver change. In our example, it was the speed. Each one of these has different speed. Speed is the independent variable or manipulated variable. The other two variables, reaction distance and braking distance, change as a result of this change in the speed. These quantities are called dependent variables because they depend on the other thing, right? The length that you take to stop depends upon your speed. How do the distances change for a given change in speed? Notice the reaction time distance increases by about the same amount for each increase in speed. Do these go up by about the same amount each time? Like from 10 to 15 is a change of 5, 7 to 11 is about 4, 11 to 14 is about 3, well that's 14.8. Yeah, they go up by about the same amount each time. When you graph this, you should get what kind of graph?
A linear.
A linear one, exactly, Lucas, and there it is. Label this one. Reaction distance. Do you know the abbreviation RXN for reaction? RXN, reaction distance. That's the linear one. Now, the braking distance, however, increases much more as the speed increases. The relationship between speed and distance can be more easily seen if the data are plotted on a graph. You can't tell whether it's linear or not just looking at this. It's hard. Numbers are hard to work with. Graphs are better. Okay? To avoid confusion, you should plot two graphs, one of reaction distance and the other of braking distance. So here is this one here is the braking distance. And this one here is the total. And they got the total by adding the two together. Different types of relationships. Would you say that if you go much faster, it's going to take you much longer to stop? Would you say that if you're going twice as fast, it's going to take you twice as far to stop?
Maybe not.
Can you tell from the graph whether that's true or not?
Yes.
I'm going to ask that question tomorrow. Your job for tomorrow is, I'm going to ask you the question tomorrow. If I'm going twice as fast, does it take twice as far to stop? Have a look at the graph, figure that out. I'll give you the answer tomorrow.
Yeah.